Hey, what's up everybody? Rob Cohey here, talking to you a little bit about what's new in Inventor 2011. In this episode, we're going to talk a little bit about what's new when it comes to simulation. Now, as you can see on the screen here, I've got a number of different level of details set up. I'm going to go ahead and turn on the level of detail simulation and switch to my stress analysis environment. Now, some of you may be a little uncomfortable in the stress analysis environment, but I can assure you some of the new functionality we've put in here is going to make it much easier to understand. So let's go ahead and determine how we're going to set up our new simulation here and carry on. Now, one of the great new things that we have with simulation in 2011 is the ability to control visualization. What's being displayed on the screen, so I can either include or not include elements of the design in my simulation. So the first thing I'm going to do is I'm going to say, you know what, that particular part of the simulation, I don't need it, so I'm going to turn it off. And then I'm going to also turn off its visibility. So now it's going to ignore it. It's going to make my meshing and my analysis much more fast as compared to had I had it analyze everything about it. Because this particular simulation, I don't need all that stuff. As you can see here, I also have an embossment on that part. So new in 2011, I can go all the way down to the part level, right click on a feature in the part within the assembly and tell it to extrude from the simulation. Again, this embossment, it's not going to do anything with the structural integrity of this part, so I can go ahead and tell it not to include in the simulation. Again, speeding up my meshing, speeding up my simulation. It's all about time, right? So let's go ahead and add some materials to this. So if I check out what materials are assigned, I can just kind of scroll through here right in the browser. I don't have to bring up a dialog box. But where necessary, if I want to go ahead and assign some materials, I'll go ahead and right-click, Assign Materials. And now I have the ability to either do a control select or a shift select to select multiple components and then assign the material properties to all those the multiple components as I have defined as part of the selection set. Now, a couple other things, I've got constraints, loads, context. Those can be a little bit overwhelming. So new in Inventor 2011, we put in a simulation guide. Now, it kind of walks you through step by step. So here I'm saying, yeah, I'm a little bit familiar with this. So let's go and teach me a little bit about constraints and what do I need for constraints. So I can just kind of read through here. It's tightly connected, or maybe it can freely slide on itself. Well, that sounds about like what I'm looking for. So I need a frictionless constraint. So it pops up the frictionless constraint. And now you basically determine, well, where are your frictionless faces. So just go through, select the faces. You can see I can pick through the surface there to do the select other. And then pick all the faces that are going to be part of that frictionless constraint. I'll go ahead and hit OK. And then carry on with my simulation guide. So I've got some cylindrical faces here, so it's telling me that, hey, you might need a pin constraint somewhere. So I'll hit the pin constraint on my simulation guide. Dialog box pops up. And I'll select the first location, hit Apply. Select the second location and hit OK. Now note the difference between hitting Apply and OK. Apply lets you continue in the command. OK actually executes and closes the command. So let's rotate around a little bit here and continue on with our simulation guide and see what it tells us what to do next. So we just did constraints. Well, what about loads? Well, let's go ahead and read through here. The model is subject to a well-defined payload, force, or pressure. Alright, so this thing's going to be in a combustion chamber. I imagine that it's going to have some pressure applied for it. So let's go ahead and set it at 3.5 megapascals, and then select all of the surfaces of this of the top of this cylinder head, because again, it's in a combustion chamber. It's going to have a lot of pressure on it, evenly distributed all the way out through the face of this piston head. So let's just select all of our surfaces, and then we'll hit OK. Alright, great. So let's go back through our simulation guide and see what else we have left. Now, contacts. Now, contacts, when it comes to an assembly, it's something where if you haven't played with it yet, it's going to be really new. So what do you got here? I've got parts that can move, slide from face to face. Alright, so yeah, that sounds about right. And they can slide against each other, but some of the things are, we've got sliding and no separation here. So first thing I'll do is let's let Inventor solve most of the contact situations for me. So it's going to determine what's bonded. Remember when I set up my simulation right at the outset, I determined what the default contact situation was going to be, and the default was going to be bonded. So it's looking at your assembly, it's looking at constraints, and it's determining what are going to be bonded constraints. And then it'll allow me to go through and analyze which ones are bonded, and whether or not I need to adjust to like a pin type or what have you right on the fly. Now while this is calculating, it may seem initially like it's taking up quite a bit of time to do it, but as you can imagine, it's doing a lot of work for you. So let's go ahead and rotate around and expand all the contacts it did for us. Again, our default was set to bonded, so as you can see, it went through and it analyzed the entire assembly and determined which of the contacts it needed to create for you. So I've got, oh wait a minute, there's one that probably shouldn't be bonded. Maybe it needs to be a different type. So let's go ahead, right click and edit those contacts and go through and pull down, sliding with no separation, hit OK, and now I have the right type of contact for this. Now let's adjust our mesh setting a little bit here, so give us a little bit more accurate reading on our mesh calculation. And let's take a look at what that looks like. So let's hit the mesh view. Keep in mind that we told it to not include that large assembly. We told it to not include that emboss, so that it's not being part of the calculation of the mesh. And as you can see, meshing is something that it's very math intense. And if I'm having it calculate like that embossment, that's not necessary. I'm using up time that would otherwise be spent on something better. So let's go ahead and run the simulation. Now, given all the things that we put into the simulation, all the contacts, the pressures, the loads, and everything, this simulation is pretty fast. So show me the undeformed or the actual display of this, so it doesn't. It looks a little more like I want it to. So as you can change it to 1-to-1, deformed, actual, a couple different options here. Let's go ahead and add a probe on one of these hotspots and see what's going on. And I want to make sure that the tensile strength for this component is within acceptable parameters. And so I can add one for displacement as well. So let's find the hotspot on displacement here and go ahead and add a probe to that. There you go. And if all these are within standard, I'm good to go. Let's go ahead and animate the results. Who doesn't like to see an animation? Especially during a simulation analysis. Now, all this information is great, but who am I going to communicate it to, and in what form do I need to communicate it? So let's go ahead and produce a report out of this. Now, with Inventor 2011, I have the ability to go through and determine which of these results I want to actually publish out to a file. Now, I've got different types of file, HTML or a rich text format, which is essentially going to spit me out an RTF file that I can open up and edit if I need to in Word. So if I want to put it into a template or copy and paste it in some company letterhead, I certainly have the capabilities of doing that. So with the simulation guide, our ability to include or not include certain elements of the design in with the analysis, the step-by-step simulation guide tool, Inventor 2011 makes it easier than ever for everyone to take full advantage of the many powerful simulation tools inside of Inventor. The simulation guide walks you through the steps required to define the best scenario to represent the particular loads or interactions. The new simulation guide makes simulation accessible even to new and occasional users by helping them set up loads, constraints, and contacts, as well as generate and interpret the results.